Hi, my name is Kara, and I'm presenting on my research project about epistemic beliefs. And I'm curious to find out if there's any connection between epistemic beliefs and a STEM-focused or non-STEM-focused area of study, age, education level, or gender. So to start with, I am interested in science education at the university level. And we know that conceptual development is a goal for university science classes. Perkins in 1994 listed 5 areas of effective conceptual development, and one of them is induction into the discipline. So for science education, induction could mean viewing knowledge in a particular way, particularly that knowledge comes from empirical evidence that is iterative and based on perceptions that are not our own but are objective. So how we approach knowledge and how we value knowledge is known as epistemic belief. So within science education, a viewpoint that is iterative, empirical, is known as positivism. And a knowledge base that is based on personal viewpoints is interpretivism. So I have a little chart here for you to kind of explain the differences between the two. For me, positivism is like if you're uncovering a fossil from a bed of rocks, where that fossil was always there. It doesn't matter if you believe it was there or not, it's there regardless of your belief. Whereas interpretivism is more like a sculptor who is creating an image of a fossil out of stone, where their perception of what that looks like will create that image of the fossil. Interpretivism and positivism are both valid points of view, but typically in the natural sciences or in STEM education, we would expect positivism to be the dominant epistemic belief or worldview. So we actually don't really know if this is true and from what vantage point our STEM instructors focus, and also what vantage point non-STEM people focus. But this is important for science education because there's some implications about epistemic belief and education. So this study purpose will clarify some of the aspects around epistemological beliefs, and particularly those related to instructors and non-STEM students. Okay, so there's a pretty extensive body of literature on epistemic beliefs. And so broadly speaking, once again, it's just how you view knowledge. And all of the studies have been categorized into 3 broad models: the multidimensional, developmental, and cognitive model. For this study, I adopted the multidimensional model, which is basically that epistemic beliefs are a series of independent systems of how we view knowledge. And so I don't really touch on developmental or metacognitive at all. So we know that in regards to how we approach knowledge and learning, that there's association with self-regulation in learning with knowledge of our own epistemic belief. It impacts motivation and classroom performance. And most importantly is this 4th point on this slide, is that students' epistemic beliefs actually change based on the cues that the teacher gives and that are given within the classroom environment, that they shift. And so what I'm most curious about is that conceptual development piece, where we want to see that if students are being inducted into the discipline of science, which is part of conceptual change, that they're going to be approaching knowledge from the same standpoint. So a couple of studies have shown us that learning frameworks, those beliefs presented by the instructor, when they match the subject material, students have better learning outcomes. And so in other words, we have this 2nd point here: the accepted worldview of the natural science is empirical and evidence-based, that positivism that we're talking about. And so we want students to share this background to learn science. That doesn't mean they have to have that point of view in all aspects of their life, but for learning science. And this would be considered being inducted into the discipline. There's been a couple of tools or surveys that have been developed to measure epistemic belief. There's a large one that was developed by Schomer in 1990. It's widely used. Almost all of the studies I read refer to this tool. but it is not reliable on the subscale level. So Bedelman and Constantinou in 28 developed another one. Their goal was to make it valid, but they're from Greece and they did it in Greek, and it's actually not validated in English. But they did split epistemic beliefs into 5 dimensions, and their third dimension aligns with what I'm curious about, looking at that positivist point of view versus the interpretivist point of view. So I compared their questions with the ones I did in my survey, and they were pretty closely aligned. So the questions for this are, what are the epistemic beliefs of general students compared to STEM instructors, and what factors, specifically education level, area of study, as in STEM or non-STEM focus, age, and gender, impact epistemic belief as far as epistemic belief is taken from interpretivism and positivism. I'm just focusing on that one small aspect of epistemic belief. So the questionnaire I developed is in 4 parts. We have demographic questions, which give me those characteristics that I want to focus on. We have a Likert scale portion, which focuses on a person's opinions about interpretivism. And they rank from 1 to 5 based on how much they agree on particular statements that relate to interpretivism and positivism. Then the next section actually asks them to determine what methodology would be the best way to figure out knowledge, to figure out valid knowledge. And that ranges from scientific testing only, that positivist perspective, to reflections and observations only, which would be that interpretivist perspective, and that's a 5-point scale as well. And the additional section is additional demographics. I wanted to find out if people are students, if they're not students, and what their gender was. I didn't have that in that first part. So this research design is naturalistic. I'm not applying any sort of treatment or anything like that. I got my participants through snowball recruitment. I really reached out to a lot of people I knew and made that link readily available. And I did that like on Facebook and sending emails and all sorts of different methods, which got me 71 people, but it was maybe not the best recruitment method to get reliable results. And we'll talk about that in a minute. So you can see on here, this is my chart of demographics. It has the different characteristics split up by how the survey was. And like I said, there were 71 people, but none of these categories have that 30 number that I'm looking for to get that central theorem ability to view this data as normal. So I actually, when I analyzed this, I considered this data to not be normal. And I also looked at histograms and it had skews and stuff. So I didn't approach it as normal data. So for some of the results, what we can see here is this. First, we're going to look at the interpretivist perspective, those opinion statements on interpretivism versus positivism. And I ran a 2-tailed t-test for interpretivist worldview based on those questions that related to that, and nothing correlated. So education level, age, gender, area of study, nothing correlated as far as what people, how they perceived interpretivism versus positivism. These are the actual questionnaire items that relate to that, and you can see the means there. And some of them, a higher mean score means a more interpretivist point of view, and some of them, a lower mean score means a more interpretivist point of view. So if you look here, this, I don't know, 1, 2, 3, 4 down, reliable knowledge about the natural world is figured out mostly through scientific testing, observation, or models. If you put strongly agree with that one, reliable knowledge about the natural world is figured out mostly through scientific testing, observations, or models, that would mean you have a positivist perspective. And this one, you can see the mean was 1.76, so that's not a strongly agree. So most people, I would say that most people were viewing that from an interpretivist standpoint. So that's that first area of questions. And I split it here, these mean interpretivist worldviews, by STEM focused and non-STEM focused. And you can see it's negligible, that difference. So everybody was kind of viewing this knowledge pretty similarly. So then the second area of the survey. It's actually the third one. It was those questions about how we determine the best methods to determine reliable knowledge. I ran a Pearson's correlation two-tailed t-test for this, and we actually did get some correlation that came out of these. And again, this is we cannot assume causation here by any means, but there is a slight correlation. So you can see here that education level was correlated, as was age. But gender and area of study are still not correlated. So we're going to look at these a little bit more specifically. So this first graph splits out the means of how people viewed reliable knowledge based on their education level. And so on all of the reliable methods, the closer to 1 that you are means that you are choosing methods that are more empirically based and from a positivist perspective, that there are those scientific, iterative modeling and modeling techniques. And so you can see the spread there of the high school, associates, bachelor's, master's, and PhD. And so this is where it did rank it as significant, the correlation. And you can see that a PhD compared to high school diploma, that the graphs are showing me that you're moving closer to that positivist point of view and farther away from the interpretivist point of view, the more education that you have. And that's the same thing with age. And so that's split up by those age groups again. So it's pretty interesting. But you can see that my data, most of the participants were in the 31 to 40 years old range. And so that kind of impacts a little bit. I only had a few that were older than 55 and a few more that were 41 or older. Okay. And then the ones that ended up not significant are gender, and there was a lot more females than males, and area of study was also not significant. So it didn't matter if you were STEM or not STEM focused. So what we found here is, if we get back to the discussions, the first question are, what are the epistemic beliefs of general students compared to STEM instructors? Well, it turns out I didn't have enough of those two categories to actually even answer this question. And so it remains unanswered, and that can be an area of future research. But this second research question, what factors, education level, area of study, STEM or non-STEM, age, gender, impact epistemic belief? And so from that first set of data where they put their own personal perspective, there was nothing that correlated. But that second set that looked at reliable methods indicated that there was a correlation between education level and age. So, and we talked about that. So that's kind of interesting, that education level and age might impact how you see knowledge and view knowledge as far as interpretivism versus positivism. But this study has quite a few limitations, so I would take that information with a grain of salt. First, the sampling was not random. I told you we'd come back to this. It was a snowball technique, and it violated an assumption of the Pearson's correlation test. We needed independent random samples, which I just did not do. The questionnaire also was not validated, so it's unclear if we actually measure epistemic belief with the questionnaire. And the sample sizes of the different subcategories are small and unequal, so it's pretty hard to make any conclusive statements about this. So future research could focus on improving the sampling method to make sure that we really get that target population of university instructors and non-STEM focused students, to see if their epistemic belief matches and if that can lead to better conceptual development in the classroom. And in general, just more robust and random samples to determine if to go on that data or that result, that education level and or age might correlate with epistemic belief. We'd want to get more information and make sure those samples are random to find that out. And then finally, we need an instrument that is valid in English and not just Greek. Anyway, thank you. I've enjoyed the semester. Here is my reference list. I hope that you enjoyed this presentation.